Yeah, yeah. 1 minute. Yeah, yeah, I can hear you. I can hear you. It's fine. Yeah, earlier you were not audible. Now it is okay. Now it is okay. Okay. Wait. Okay, all right. I'm sharing the screen, and I think you must be. 1 minute. Yeah. We will quickly revise all the concepts about the structure of atoms and further atoms and molecules. Okay.
Okay. You observe from very beginning. It's
It's
here
here
for
for you.
you.
First,
First,
we
we
understand.
understand,
Try to
try to
understand
understand
what
what
is
is
this
this
atom.
atom.
And when we
And when we
consider this
consider this
atom
atom
in
in
our
our
discussion,
discussion,
we
we
call
call
this
this
as the
as the
smallest
smallest
identifiable
identifiable
division of
division of
any
any
element.
element.
That
That
means
means
the
the
smallest
smallest
part
part
into
into
which
which
an
an
element
element
can be
can be
divided.
divided.
You
You
can't
can't
further
further
break
break
atom
atom
if you
if
want
you
any
want any
identifiable
identifiable
entity.
entity.
In this
In
way, we
this way,
can
we can
define
define
the atom.
the atom.
And we can
And we can
consider this
consider
to be
this to
as
be as
the
the
smallest unit
smallest
of
unit of ordinary
that
matter
forms a
that
chemical
forms a
element.
chemical element.
Actually, all
Actually,
kind
all
of
kind of
solid, liquid,
solid,
gas,
liquid, gas,
plasma.
plasma.
These are
These are
actually
actually
five
five
states of
states of
matter that
matter
we
that
have.
we have.
What are
What
those
are
five
those five
states of
states of
matter that
matter
we
that we
actually have?
actually have?
These
These
are
are
these are
these are
five
five
states that
states
you
that
can
you can
observe here.
observe here.
These are
These are
solid,
solid,
liquid,
liquid,
and
and
gases, the
gases, the
main
main
states.
states.
And later
And later
on,
on,
we
we
also
also
have
have
states like
states like
we also
we
So,
have
also have
sir,
states,
states,
yeah, like
yeah, like
plasma
plasma
and
and
BEC,
BEC,
Bohr,
Bohr,
Einstein,
Einstein,
condensate.
condensate.
so, sir,
Okay,
plasma is
yeah.
basically like a heated type of gas, or what is it again?
Actually,
Like,
Actually,
heating
heating
gases are
gases are
involved in
involved in
plasma.
plasma.
The
The
gases in
gases in
heated
heated
form are
form are
involved here
involved
in
here in
plasma
plasma
state.
state.
Actually,
Actually,
you
you
can
can
consider
consider
sun
sun
to
to
be
be
in
in
the
the
plasma
plasma
state.
state.
The
The
gases in
gases in
sun are
sun are
helium
helium
and
and
hydrogen
hydrogen
actually.
actually.
There are
There
two
are
yeah.
two
kinds of
kinds of
gases there
gases
in
there in
sun.
sun.
Those are
Those are
hydrogen and
hydrogen and
helium.
helium.
And these
And these
reaction
reaction
perform
perform
these
these
reaction
reaction
actually
actually
cause a
cause
very
a very
important
important
reaction there
reaction
that
there
is
that
known
is
as
known as
nuclear.
nuclear.
You just
You
write
just
it is
write
very
it is very
important thing.
important thing.
Nuclear
Nuclear
fusion.
fusion.
And due to
And due
this
to
Yes,
this
sir, I've
nuclear
heard of it.
fusion,
fusion, yeah, yeah.
Due to
Due
this
to this
nuclear
nuclear
fusion,
fusion,
we
we
can
can
we
we
can
can
find
find
the
the
very
very very very
large
large
amount of
amount of
heat
heat
there,
there,
and that is
and that
why
is why
gases
gas
are
are
there
there
in
in
heating
heating
state,
state,
heating
heating
gases we
gases we
can
can
say.
say.
And in the
And in the
BEC,
BC,
Bose-Einstein
Bose-Einstein
condensate, the
condensate, the
separate
separate
atoms
atoms
and
and
separate
separate
particles
particles
are
are
cooled at
cooled at
0
zero
Kelvin. That
Kelvin.
is
That is
heated
heated
gases.
gases.
Okay,
Okay, actually here as well,
the things
the
are
things
here.
are here. Heated gases is not here.
Heated
Heated
gases
gases
is
is
for
for
plasma.
plasma. I have just shown this diagram.
And in
And
this
in this
diagram,
diagram,
you are
you are
actually
actually
able
able
to
to
see
see
this
this
pattern
pattern
that
that
solids are like this,
they are closely packed,
they
they
have
have
very
very, very lesser
gap
gap
between
between
those
those
matters,
matters,
and
and here again,
those
those
matters
matters
are
are
obviously
obviously
atoms.
atoms.
Similarly,
Similarly, in case of liquid, the gap is bit more.
in case
In
of
case
gas,
of gas,
even
even
more
more
gaps
gaps
are
are
there
there
between
between
those
those
particles.
particles.
In
In
case
case
of
of plasma,
the
the
gap
gap is more,
but
but
they
they
are
are
in
in
heated
heated
version.
version.
That is why there is
much more
collisions
collisions
among those
particles,
particles,
you can say.
Is it
Is
okay?
it okay?
Here I've
Here
also
I've also
explained
explained how to convert
these
these
temperatures.
temperatures. If you want to convert
Temperatures
temperatures from SI
unit,
unit, that is Kelvin, to
degree
degree Celsius, that most common used unit, you can use this formula.
K,
K,
which
which formula can be used here?
The
The
formula
formula
goes
goes
like
like
this.
this.
K
K
is
is
equal
equal to
K
K is equal to
C
C plus
273.
273.
What
What does
K
K over here
means?
means? K means temperature in Kelvin.
If you
If you want to convert
any
any temperature in Kelvin
to
to temperature in degree Celsius, what will you do? You just write your Kelvin here. You just write the value of K here. You will be able to convert.
Here
Here K means Kelvin, C means degree Celsius.
If you are
If you are given with C and you want K, you can do that.
Or
Or if you are given with K and you want C, you can do that. Let's say here you are given with 0 Kelvin and you want to convert it into degrees Celsius. What will you do? You will put 0 in the place of K.
Then you will
calculate C, that is coming out to be minus 273 degrees Celsius. This is the temperature where we cool these gases. Here we are heating these gases. And here we are cooling them at this level.
These
are just opposite states of matter, you can see. You are familiar with the first state of matter, solid, very much familiar with this. You are also familiar with this second state, liquid. You are also familiar with this third state, gas. Actually, these are different kinds of matters which can be categorized on the basis of their properties. What are different properties that we have here with those solid, liquid and gas? Can you tell me some of the properties?
So properties in gases,
Yeah, properties of these three, solid, liquid and gases.
as like examples. Okay, so for example, in solids there are like everyday things which you see around us. For example, let's say a bottle, a paper, and stuff like that, which can't be
exactly.
you know, which how can I say? Can't be
Yeah.
solved.
Okay. I will give you some points in which you can categorize them. You don't worry. I'm just presenting some of those points in which you can categorize all of them. Okay, I'm just mentioning those points, and it's your task now to decide all these cases. Okay, the first task is mass.
What do you say about mass of solid?
What do you say about mass of liquid? What do you say about mass of gas?
Which one has
Which one has
how much?
Higher mass?
Do you think they all have definite mass?
They all
have fixed mass?
Yes, sir.
Yeah.
Actually, we will put the word definite here in all of these cases. They all have definite masses. Okay. Second criteria that I'm considering here is shape. What do you think? What do you think about their shape?
Shape, like
What do you think
about shape of solid?
sir, the shape of solid can be anything, I guess.
Yeah, obviously. But it is always fixed. If it is
cuboidal
or it is
definite that I mean.
Definitely.
If it is cube, we have definite. Right now, if you consider my room from where I'm teaching right now, it is a quite cube kind of room where all length, width and height are quite similar. That's why I'm saying cube.
Here
the shape is similar. The shape is definite. That is, it is cubical. Maybe cuboidal. Maybe somewhere you see the figures like cylindrical or conical or frustum kind of figures, like bucket is a frustum. And many such solid geometry or solid figures exist. But do remember they are definite in shape.
But in
But
case
in case
of
of liquid,
the
the
liquid
liquid
has
has
not
not definite shape
or
or
definite shape.
definite
What do you
shape. What do you
think?
think?
Mm,
Actually,
Actually,
liquid has
liquid
not
has not
definite shape.
definite shape.
They
They
acquire the
acquire
shape
the
of the
shape of the
container.
container.
What
What
happens with
happens with
liquid?
liquid?
so they need, yeah, you need to put the liquid in something where it can like
Yeah,
not
Yeah,
move
exactly,
around
exactly,
freely.
exactly,
So
exactly,
exactly. If
exactly.
you
If
are
you are
putting
putting
liquid
liquid
in
in
a
a
bottle,
bottle,
contain.
a
a
container, if
container, if
container is
container
in the
is in
shape
the
of
shape of
cylinder, they
cylinder, they
gain the
gain
shape
the
of
shape of
cylinder.
cylinder.
If you
If
put
you
it in
put it
the
in the
conical
conical
container,
container,
the
the
water,
water
the
or the
liquid gains
liquid
the
gains the
shape of
shape of
cone.
cone.
If you
If
put
you
it in
put it in
somewhere
somewhere
else,
else,
it will
it
gain
will
the
gain the
shape of
shape
that
of that
container.
container.
What
What
happens with
happens with
liquid?
liquid?
It
It
gains the
gains the
shape of the
shape of the
container.
container.
Similarly, the
Similarly, the
same thing
same thing
happens with
happens with
gas.
gas.
Gas
Gas
also
also
acquire
acquire
the
the
shape
shape
of the
of the
container
container
where you
where you
actually
actually
put the
put the
gas.
gas.
Gas
Gas
also
also
acquire
acquire
the
the
shape of the
shape of the
container.
container. Right
Right
now,
now,
you
you
can
can consider
consider
one
one
of
of
the
the
example of
example of
this.
this.
Can you
Can
tell
you
me
tell
one
me
of the
one of the
example
example
of
of
such
such
such shape
shape
base
base
example,
example, shape base example
that we
Okay,
that
did
we
so
in
did?
so
Yeah.
domestically we
Domestically, we
use.
use.
Yeah,
Yeah,
tell me.
tell me.
First
If
you tell
first
me,
you
then
tell
I
me,
will
then I
tell
will
one
tell
more
one more
example.
example.
okay, so for solid, let's say a keyboard probably.
Yeah.
Solid is
Solid is
obviously no
obviously
doubt.
no doubt.
Keyboard is one
Keyboard
of
is
the
one of the
solid
solid
object,
object.
and
And
water
water,
you are
you are
considering
considering
water in
water in
glass
glass
is a
it is a
liquid.
liquid.
What
Yeah.
about
What about
gas? How
gas?
can
How
we
can we
So
consider?
consider?
gas, for example, Earth. I mean, there is air, there's oxygen, there's carbon dioxide. There are different gases which is trapped inside the Earth.
Yeah,
Exactly.
exactly.
Gases are
Gases
there
are
in
there
our
in our
atmosphere, and
atmosphere, and
entire
entire
atmosphere is
atmosphere
filled
is
with
filled
these
with these
gases. That's
gases.
okay.
That's okay.
Even
Even
in
in
our
our domestic
domestic
example, if
example,
we
if we
want
want
to
to
put,
put, in
in
kitchen we
kitchen
make
we
use
make
of
use of
LPG
LPG
gas.
Natural gases,
gas.
yes, sir.
Yeah.
And in
And in that, you
you
consider
consider
that
that
cylindrical
cylindrical
kind
kind
of
of
a
container
container
where we
where we
fill
fill
about
about
14
14
point
point
something
something kg
gas
gas
Yeah,
we
sir.
fill
fill
in
in
that.
that.
And
And
it is
it is
actually
actually
you can
you
even
can
put
even
more
put more
gases in
gases
that.
in that.
It can be
It can be
Yes, sir.
compressed
compressed
much,
but
but it is
the
the
Heavy.
safe
that is
range.
why
That
we
is why
put
we
that
put
much
that much
gas.
gas.
And
And it can gain again. It can again gain any shape. Wherever you fill it, it can gain the shape of that.
Okay.
Okay.
But it can't be seen properly.
It can't
It
be
can't be
seen. That
seen.
is
That
why
is
we
why
put
we put
some
some
other
other
stuff,
stuff,
other
other
material that
material that
help us
help us
to
to
smell it.
smell it.
Do you know
Do you
what
know
do we
what do
put
we
there
put
in
there in uh,
LPG? Which
LPG?
gas
Which
is
gas is
used
used
so
so
that we
that we
The
can
can
get the
get the
order?
order?
that I don't know.
Because
Because
actually
actually
that
that
LPG has
LPG has
no
no
which type
which
of
type of
carbon
carbon
compounds are
compounds
there
are
in
there in
LPG?
LPG?
The
The
Carbon
LPG
and
LPG that
LPG that
LPG
we
that we
use in
use
our
in our
kitchen
kitchen
is
is
actually
actually
liquid
liquid
petroleum gas.
petroleum gas.
And in
And
this
in this
liquid
Ah,
petroleum
liquefied, it is in
liquefied form.
liquefied form.
And in
And
this
in this
liquefied
liquefied
petroleum
petroleum
gas,
gas,
we
we
make use
make
of
use of
carbon
carbon
compound like
compound like
hydrocarbon we
hydrocarbon we
actually make
actually
use
make
of.
use
What
of.
do we
What do
make
we
use
make
of?
use of?
Hydrocarbon.
hydrocarbon.
Hydrocarbon means
Hydrocarbon
the
means the
compound of
compound of
carbon and
carbon and
hydrogen.
hydrogen.
Yes, sir.
Okay?
Okay?
In
In
previous
previous
class,
class, even I have
you
helped you
with
with this
that
concept
there
that
are
there are
compounds.
compounds. If you are just considering different atoms in definite ratio, you will get molecules as well as you will get different compounds. Here I'm considering compound of carbon and hydrogen
that are
that are
going to
going to
form
form
LPG
LPG
gas.
gas.
What are
What
those
are those
compounds
compounds
that
that
are
are
forming
forming
LPG?
LPG?
You need to
You need to
remember that
remember
they
that they
are
are
propane,
propane,
they are
they are
butane,
butane,
they are
they are
propylene,
propylene,
butylene, and
and
isobutane.
isobutane.
Basically,
Basically,
there
there
are
are
two
two
important
important
compounds
compounds
that
that
form the
form the
LPG.
LPG.
100% propane may be there, or there may be 60% propane and 40% butane. 5 carbon you call it pent, and if it is alkane you call it methane, if it is alkane you call it ethane, there may be alkene as well, there may be alkyne as well. Okay, got it? Okay.
Yes, sir.
Okay. These are different compounds that are there, which are carbon compounds, carbon and hydrogen compounds. There are ultimate infinite many carbon and hydrogen compounds that exist here. Because carbon has tetravalency and catenation power, and that is why it can form many carbon compounds. But out of those carbon compounds, LPG contain propane and also contain this one. First is methane, second is ethane, third is propane, third one propane, and fourth one butane may be there. Okay, basically it contains either 100% propane or 60-40 ratio can be considered. Okay, you just mute yourself and unmute when you want to ask question. Do that. Okay, I think you are okay up to this. Now after shape that we have considered, I want you to tell that it is very flammable mixture of these hydrocarbon gases, and these what do we mix? We actually mix some stuff so that it can be smelled, because it is very flammable. And I want you to tell me which compound do we mix in order to identify smell, to identify or to smell it, because actually actual mixture is not that what should I say? Actual mixture of propane and butane even is not. It is actually orderless, I should say. It has no order. That's why you can't smell even if there is leakage. That is why it is very much needed to mix something else so that you can smell it, so that you can know whether there is any leakage or not. It is obviously a general knowledge concept that you should understand. Do you want to know which gas we mix here? I want you to understand this. We actually mix ethyl mercaptan here, which possesses that strong order of rotten cabbage. Okay, rotten cabbage order is there in this. No, it is. Now you need to buy a cabbage and then left it for this state. Then only you can understand how does it. What is the order of rotten cabbage? But it is actually found that the smell of that ethyl mercaptan that we mix here. What do we mix? Ethyl mercaptan. It is another gas that we mix. Question arises: why do we mix this ethyl mercaptan? Is it needed to make LPG burn? No, it is not needed to make it burn. But it is needed to make it know whether there is any leakage or not. That is why we mix this as well. Okay, it is a GK point of view. I have explained it. Is it clear up to this?
Yes, sir.
Yeah, now I want you to understand some other points related to this. And the next point that I want you to understand here is point related to there is volume. What about volume? Just tell me what about volume of all of them. They all have definite volume. They all have definite volume.
Yes.
Or they all don't have definite volume. What do you say? Actually, gas don't have definite volume. Actually, gas don't have definite volume. Because gas gets spread everywhere. That is why
gas has indefinite volume.
After
volume, there is compressibility. Which one is more compressible? Which one is less compressible? Can you tell me which one is more compressible?
Gas
is much compressible. You can compress as much as you want.
The
less compressibility is there,
and not possible. You can't compress solid.
But you can.
There is very negligible way to compress liquid. But there is much compressibility, high compressibility.
Yeah.
What about
fluidity? Fluidity.
Not possible. Solid
doesn't fluid. Gas and liquids are flowable.
Rigidity.
Solid is highly rigid. Gas is not rigid. Liquid is less rigid. Diffusion.
Solid has
no diffusion power, or slow you can say. Liquid is fast and diffusion power of gas is very fast.
And space between particles
for solid, it is so less. Most closely packed, less closely packed are liquids, and least closely packed are those gases.
And
interparticle force is definite
and slightly weaker in solid than solid in liquid, and negligible in gas.
Those forces between particles is higher in this solid.
Okay,
in this way, by considering these points, you can define, you can differentiate among solid, liquid, and gas. Is it clear to you?
Yes, sir.
Okay, so far I have helped you with the definition of atom.
That is
the smallest part into which an element can be divided.
An atom is the smallest unit of ordinary matter that forms a chemical element. Every solid, liquid, gas, and plasma is composed of neutral or ionized atom. Now I will explain how atoms get ionized. You don't worry that. Atoms are extremely small, typically around 100 picometers. Picometer. In 1 picometer, there is 10 to the power minus 15 meter. 1 picometer is equivalent to that. How much?
10 to the power minus 12 meter actually, not 15. Yeah. In 1 picometer there is, but it is saying 100. That is why we will consider 10 to the power minus 10 only, isn't it? In 1 picometer there is 10 to the power minus 12. And 100 picometer is about to 10 to the power minus 10. That is 1 angstrom. Okay. The size of
atom.
About 1 angstrom. 10 to the power minus 10 meter is 1 angstrom. This is the angstrom. And 10 to the power minus 9 meter is 1 nanometer. That means in actually 1 angstrom there is 10 nanometer. In one, what can I say here? In 1 angstrom there is, in 1 nanometer there is 10 angstrom, because you can write it as 10 to the power 9 into 10 to the power minus 1 is equal to 1 angstrom. This is written as 1 nanometer, and you can shift this here. It will be 1 over 10 and then it becomes 10. In 1 nanometer there is 10 angstrom. You can just do write like that. Actually both are very smaller unit. The size of atom is generally measured in angstrom. Got it? Even you can measure it in nanometer. If it is even smaller, you can measure it in picometer. 1 picometer is 10 to the power minus 12 meter. 1 angstrom is 10 to the power minus 10 meter. 1 nanometer is 10 to the power minus 9 meter. 1 nanometer is actually 10 angstrom. We have determined these smaller units. Then we have understood how to convert the temperature from Kelvin to degrees Celsius and degrees Celsius to Kelvin. We also came to understand, came to know this.
Then we covered what is states of matter, and we came to know about solid liquid gas, and we differentiated, we have just created some points through which we have categorized the difference in solid liquid and gas, and we came to know about the composition of LPG, that is liquid petroleum gas. It contains propane, and there is many variety where we have only propane, and there may be that we have propane and butane in 60-40 ratio. In plasma state, there are gases in heating state, heating gases, very high temperature, gases in very high temperature, and in those, in that fifth state, Bose-Einstein condensate, the atoms are cooled at very low temperature of minus 273 degrees Celsius, that is 0 Kelvin. In one there is gases in heated version, in another the gases are in very cooled state, they are cooled in very lesser temperature. If we want to understand what is, if you want to note it down, you do note, if question arises that whether atoms are the smallest possible, the answer is actually no. Because even atoms can be further divided into proton, neutron and electrons. That is why we call them subatomic particles. There are three subatomic particles, one of them is proton, another is neutron, and one of them is electron. Out of these three, proton and neutron lies at center and they form the entire mass, and electrons are revolving around these proton and neutron, that is center. Okay, after this, I'm now going to help you with this kind of solid, liquid and gases, and even plasma exists there in our Earth as well. The Earth atmosphere is made up of these gases, oxygen in maximum form, nitrogen is in oxygen is also there, nitrogen in highest form. What is the composition of our atmosphere? What are composition of atmospheric gas? Do you know that? How much nitrogen? How much oxygen?
Sir, oxygen is about 96 or something.
Oh, no, it's not like that. Actually, there is 78% nitrogen. The nitrogen in the maximum. Yeah. Oxygen is about 21%. Okay, it combined to form 98. 98? Yeah, it's 99 about. Then there is about 0.93%, or about 1% even. Argon is much there. After nitrogen and oxygen, argon is very, you can say it is very less, but still it is about 1%. It's 0.93%. And in other point, 0.07%, there is carbon dioxide, which is 0.003%. 0.0 Yeah. 0.03%. There is carbon dioxide. How much? 0.03%. And some other gases are also there. Okay. Even you need to understand this. You can just approximate it in this manner that there are total 78% nitrogen, there are 21% oxygen, and about 1% remaining 1% is your argon. These are three gases in maximum form. This carbon dioxide, which is so less, if increases, may cause very dangerous issue, that is global warming, responsible for greenhouse effect. And there is solid, Earth has solid state as well. Deep within that there is plasma state as well. There are liquid state as well.
If you consider Earth surface
and
and you want to know
how much
water
and how
much land
in
in Earth's surface.
You
want to know how much water is there in Earth's surface?
Yes, sir. There is how much again? 70.
In Earth, about
71%
of
of Earth's surface is water.
This
Around
around
71% of Earth's surface is water, where we can't live actually. 71% is water, and out of this 71% which you call water, how much is ocean? About 96% is ocean.
Yes, and then there is how many for ground?
About 97% even.
About 0.9 or something. I don't know. So?
Yeah. About 96.5% is actually ocean. You can write it 97 even, approximately 96.5% I'm mentioning here. 96.5% is ocean, and then there is 3%, about 3% water is there that is from lake, rivers that we drink. Drinkable water is only about 3.5 and 3%. About 3.5% water is drinkable.
And
remaining 29% surface is going to be
the
the area where we live, or maybe there are forests. Okay?
Is
it clear to you?
Yes.
About
about
97. Yeah. Tell me.
Oh, not 97.
Yeah.
Okay.
Whenever we consider this Earth, we came to know that there is solid, there is gases, there is plasma state, and there is also liquid state that we find here on Earth's surface.
Okay,
again I have explained what is an atom in much detail. Atoms make up the matter that is around us. We have already covered that matter can be of 5 state.
And now the question arises,
atoms are the basic building block of matter. And if you want to remember the exact definition, you can even remember like this. Atoms are the smallest particle of an element that has all the elements' chemical properties. If you consider stars, steel and ice cream, they are some matter.
Only
a few kinds of atoms combine in different ways to produce all the countless substance on the earth. It is also important thing. Atoms, how do we know this? From where has it been originated? The answer is it has been originated from a word atomos, meaning indivisible. From Greek word atomos, we can conclude that it is indivisible. Earlier Dalton has considered it indivisible. But nowadays we find that it is not indivisible. There are subatomic particles as well. But you can remember atom as smallest identifiable unit of an element. If you consider nitrogen gas, it is the molecule of nitrogen, but it has same kind of atom, that is nitrogen atom. When we consider subatomic particles, these are subatomic particles, proton, neutron and electron, where I have already told you that proton and neutron are in the center, and electrons revolve around the center. And there is also very important limit. There are different orbits that there is a center and there is different orbits. The first orbit is called as k orbit.
Second orbit is called as L. Similarly, third is M, and the next one is N. Out of these different orbits, there is formula through which we can understand how many electrons reside here. In the first orbit, the electrons that can reside can be obtained using formula. I have already covered that. And now there is the option that orbit scale Mn. We have already understood number of electrons. We just covered it. And entire subatomic particles, now we are going to consider them and their charges and masses, and their who has discovered them, we will cover that as well. First subatomic particle is proton, which was discovered by the Rutherford. You can see the figure here. It is positively charged particle, and it has the charge 1.6 into 10 to the power minus 19 coulomb. Its mass is 1.673 into 10 to the power minus 27 kg. And then we have neutron, which was discovered by James Chadwick. It has no charge, that means it is 0 coulomb charge. And it has the mass of 1.675 into 10 to the power minus 27 kg. And then we have electron, which was discovered by J.J. Thomson. It is negatively charged particle, and it has mass which is very negligible, 9.1 into 10 to the power minus 31 kg. Negligible mass.
Sir?
Yeah.
Yeah, sir. Is it fine if we continue tomorrow, because I have to have my dinner?
Yeah. Wait, only 5 minutes. I'm going to continue it further. These are the order that you need to remember: mass of neutron, mass of proton, and mass of electron. This is the order. Okay. Then we have definitions of this. Yeah, we will quickly cover this. You don't worry. Then we will continue tomorrow. You just go through immediately. Atom is a particle of matter that characterizes a chemical element. An element is a substance that is made up of one kind of atoms, and they may be sodium. I have just given you list. I will show you once again. A molecule is a substance that contains two or more atoms. You can just see H2O2 as an example. Compound is again substance which is made up of two or more different elements. Do remember that. They are chemically joined: H2O, CO, NaCl. They are example of compound. As we understood what are elements, now you need to understand what are different type of elements. There are 118 elements, some of them of metals, that are 93 metals, 18 non-metals and 7 metalloids. In modern periodic table, they are divided in S block, D block, P block and F block. Initial two groups are S block, then 3 to 12 are D block. Then 13 to 18 are P block, and last below 2 rows are F block. You can observe it here in periodic table that look like this. Even this. You can observe initial two. The vertical, the columns are known as the columns that you see are known as group, and rows that you see are known as period. Here, how many groups are there? Here you can see that there are 18 non-metals, and also there are 18 groups, and there are 7 periods in which you can divide entire elements. You remember that those groups are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, in which 1 and 2 groups form S block, 3 to 12 form D block, 13 to 18 form P block. Out of them 17 form chlorine, bromine, iodine. They are known as halogen. Then the last 18 group, helium, neon, argon, krypton, xenon, radon, are noble gases, inert gases. Here this one is argon, that is found in approx 1%, 0.93% in our atmosphere. And these are inert gases, don't react much. That's why we call them noble gases. Then they all are D block elements or metals. All S block elements are metals except hydrogen. And these P blocks, these are metalloids, and then they are non-metals. These 17s, these 7 are boron, silicon, germanium, arsenic, antimony, tellurium, polonium. They are
7 elements which are metalloid, and remaining 18s are non-metals. And other in below two groups, two rows I should say, are lanthanides and actinides, which are F block elements and also metal. Then I want you to remember these orders. Remember up to 20 at least. I will just tell you. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Then there is oxygen, then fluorine. 10th number is neon. Then we have sodium, magnesium, aluminium, silicon. 15th number is phosphorus. Then 16 atomic number is sulfur. 17 is chlorine. Then we have argon 18, 19 potassium, then calcium. Their atomic masses you can remember. Some of them you can remember. Then we can categorize their atomic number. If we know atomic number, we can tell that there is proton and electrons equal to that atomic number. Atomic mass is equal to number of proton and neutron. You can also find number of neutron if you are given with atomic number and atomic mass number. Isotopes are those which have same atomic number but different atomic mass. Carbon is having isotope 6C12, 6C13, 6C14. Similarly, deuterium, protium, deuterium, tritiums are 3 isotopes of hydrogen. One more term is there, isobar, different atomic number but same atomic mass. Argon and calcium form isobar because they both have 40 as atomic mass, but they have different atomic number, 18 and 20 respectively. Then I have given you some questions where you can determine the number of neutrons, and we have just calculated using the formula. A is equal to P plus N, and here P is equal to Z plus N. Suppose here I want to find out. Then A is equal to 235. Z is equal to 92. We want N, you just need to subtract 92 and you will get 143. That is your neutron. It's so easy to figure out. Similarly, you can find out number of neutron in all of these examples. I have given many examples. You can just go through this. These are many examples we have solved in previous class. Then we came to know about models. When we consider the structure of atoms, there are 4 models developed. Dalton's atomic model, Thomson atomic model, Rutherford atomic model, and Bohr's atomic model. In Dalton's atomic models, elements are made of tiny particles, you name it atom. All atoms of given elements are identical, but the of different elements are not identical, they are different. Atoms of one element can combine with atoms of other element to form compound, and a given compound always has the same relative numbers and types of atoms. Atoms of this one is not valid today. Atoms are indivisible in chemical process. It was explained by Dalton atomic theory, was one of the postulate of Dalton atomic theory, which is not correct nowadays. Drawback, you can see the indivisibility of an atom was proved wrong. And in Thomson atomic model, he was also wrong because he considered it as watermelon, where you consider those seeds as electron and this eatable part as positive charged proton that you can see from here. In Rutherford atomic model, again, you can observe the postulate. According to postulate of again, you can go through the number of electrons that I have already explained. Then valence and valency. Valence electrons are the number of electrons in the last orbit. Valency is the maximum number of electrons that an atom can lose or gain. Beginning of the session. Got it? Got it now what is cation and what is anion? Anion is formed due to gain of electron.
Yes,
Sanket, let me know whether and cation is formed due to loss of electron. Know that. Here chlorine is one of the anion. Similarly, we have many cation and anion. Like hydrogen has also cation format and anion format that I want you to understand. And if you know these valencies, you can form compound as well. I just want you to go through this once. Hydrogen, sodium, iron, silver, iron. They are monovalent and many of them are here bivalent like barium, calcium, magnesium. They are bivalent. Then some of them are trivalent like iron third, aluminum. Trivalent. There are some other negative ions which are
chlorine, bromine, these are chloride, bromide, fluoride. They are monovalent negative ion. Then we have some uh, compound form of ions are also there. If you want to form any compound like sodium sulfate, like I want to form magnesium sulfate, let's say I want to form magnesium sulfate. What can I do here? I will write the symbol first, which is magnesium and which is sulfate. Then I will write their charge. Mg has +2 charge, sulfur has -2 charge. Now we will cross them and we will write Mg2, then SO4 2. As they have 2, you can just consider the simplest ratio and you can divide both sides by 2, both uh, subscript by 2, and you will get MgSO4 as the formula. Similarly, you can find out Na2SO4. Similarly, you can figure out aluminum sulfate, Al2SO4 whole thrice, and many compounds and formula can be derived, like here, calcium sulfate, barium phosphate, ammonium sulfide, ferrous sulfate, sulfite, and ammonium carbon dioxide. They all can be formed. Sodium oxide, you can figure out Na2O, and it's easy to design any compound. Now it's your homework. I want you to write down the formula of these questions. Write it down, and then we will end with this session. Okay? Write the first. First barium chloride. I'm giving you some of the compound in their common name. Then you need to figure out their molecular formula by using that approach I've explained above. There is aluminum chloride, the next question, or aluminum iodide. I can write, no issue. Then I have silver nitrate, I want you to write. Then there is magnesium phosphate, I want you to write. Then there is potassium sulfide, I want you to write. Then there is sodium sulfate, I want you to write. And there is sodium nitrate, I want you to write. Then there is magnesium phosphate, I want you to, I have already given that. Magnesium sulfite, I want you to write the formula. Okay, you write all these 8 formula. Okay, I'm giving 2 more. Then there is potassium oxide, you need to write. And the last one is, you can see here what are different compound. These are different. Okay. Here as well, sulfate, sulfide. Okay. Carbonate, hydrogen carbonate. I'm writing one. Calcium carbonate as well. And one aluminum carbonate may be there. Then there may be magnesium carbonate. You write all these 12, and I'm ending with